Okay, so 4-2, we are measuring angles in triangles. We actually have 3 theorems to look at today. Let me grab my pen. All right. All right, so the first theorem is theorem 4-1. It has a name. It is called the angle sum theorem. You actually already know this theorem. What do you think the angle sum theorem related to triangles means?
All triangles.
Yeah, the sum of the interior angles of the triangle add up to 180. Don't you already know that? You know this theorem. You don't really have to memorize it, but you need to know what it's called. So it says the sum of the measures, that was Tyler yawning, of the interior, yes, angles of a triangle is 180 degrees. Yes. As long as you move it back later. All right, so I'm going to do a very, very simple word problem with you. Now, bear in mind that this word problem will be much more complicated in your homework. They're not going to give you exact angle measures. They're going to give it to you in expressions like one angle is x plus 5, the other angle is 2x, and the third angle is x. What is the measure of each angle? You would use the sum angle theorem for that. So I'm just going to give you a very simple example because we are reviewing 4-step again, and we're reviewing just this theorem. We'll get to some more difficult ones in a minute. A surveyor has drawn, for some unknown reason, a triangle on a map. Actually, surveyors use triangles on their maps often to locate various points. But he's drawn a triangle on a map. One angle measures 53 degrees and the other measures 42 degrees. Find the measure of the third angle. Isn't that a word problem? Yes or no? Yes. So shouldn't you be doing the 4-step plan? Yes, and I realize it's a very simple word problem, so we're practicing, however, even when it's simple, setting up your equation to solve. Please quit with a squeaky chair. So what should you do on your let statement? Draw a triangle. And I'm guessing with my experience that it's going to be an acute triangle. So I'm going to draw an acute triangle. They didn't tell me what its vertices are called, so I'm going to give it my own name for the vertices. A, B, and C. So one angle didn't tell us which, but one angle is 53 degrees, so I'm going to say that this one's 53 degrees. The other one's 42. I choose that one as 42. What am I going to let B be? X. You have to have X in your let statement. If there's no unknown there, it doesn't count as a let statement. What's my equation going to solve going to be? 53 plus 42 plus X equals 180. I know that you want to do scratch over here, but I don't want to see scratch. I want to see algebra. Furthermore, remember that this is going to be like 5x plus 2, and this will be 3x. So they will be expressions that you have to add together to set equal to 180. So we're putting this in your notes so that you understand what you're supposed to add together. All right, so over here, what's 53 plus 42? 85 plus x equals 180. Subtract 85, what do you get? Oh, so sorry, you're right, 95. Oops. So we're subtracting 95. All right, so what's x going to be?
85.
Everybody agree? 85? Does that answer the question? It says what is the measure of the third angle. You cannot say therefore x equals 85. That's not a sentence. So remember that triangle of dots, dot, dot, dot means therefore. So therefore, the measure of the third angle is, and you can't just say 85, you have to put a degree marker on it. So that's not too bad, right? Trust me, they're a little bit more difficult in your homework. All right, so look at, we have two more theorems. So theorem 4.2. It actually has a name. It's called the third angle theorem. We're going to write it down, and then I'm going to explain it. It's a logic reasoning puzzle. The third angle theorem says, and this is used often in proofs, if two angles, use your shorthand notation, if two angles of one triangle are congruent to two angles of another triangle, then you ready? The third angles of the triangles are congruent. So let's think about this. You have two triangles, right? On this triangle, two of the angles are exactly the same measure as two angles on this triangle. What do both triangles' angles add up to? 180 degrees. So let's say on triangle A over here we have angles that are 50 and 110. What does that add up to? 50 and 110. 160. Let's say on the second triangle we also have 50 and 110. What does that add up to? 160. What's left in both triangles for the third angle? 20. Don't they have to be equal? Now the triangles themselves might not look alike because one might be small and the other one really big, and their interior angles can still maintain and be the same. So essentially, if you have two angles on one triangle that are exactly the same as two on the other, we know by logic reasoning, by using the angle sum theorem, that that third has to be the same. Has to be the same. All right, last theorem, and then we have one more problem to do. You need room to draw a little picture. Theorem 4-3. It is called the exterior angle theorem. That was Tyler again. Tyler's tired. It's Friday. All right, this one says the measure of an exterior angle. Doesn't that imply that that angle is on the outside? Okay, I'll tell you what an exterior angle is in a minute. So the measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote angles. And I'll tell you what remote angles are here shortly. Okay, so the measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote angles. It'd be handy to know what they look like. So you're going to draw a picture. I'm going to draw an obtuse triangle. It doesn't have to be obtuse, but it's just kind of handy for our purposes. So I'm going to draw down here an obtuse triangle. But this works on any triangle. And I'm going to label my triangle ABC, just to be boring. All right, here's what an external angle looks like. I can take any side of a triangle, any side, and I can lengthen that side by drawing the line longer. Do you see how I get an angle right here outside of the triangle? Do you see how this angle here makes a linear pair with this other angle here? The exterior angle will make a linear pair with one of the angles of the triangle. So I could do that over here too. I could extend this side over here longer. Wouldn't that be the exterior angle there? Because it forms a linear pair with that angle. Or I could extend this side out longer. This angle here forms a linear pair. And I can do it on either side, like I could do it over here. This angle down here would have been the linear pair. So let's go ahead and extend AC. I'm going to extend it with a dotted line, because it really doesn't belong to the triangle. And this angle right here is your exterior angle. Now, we have to look at what the remote angles are. If this is the exterior angle, and the theorem says that it's equal to the sum of the two remote angles, would you consider this angle C here remote to this exterior one, or next to it? Is anybody next to you considered remote, far away? If the person right there is sitting next to you, do you consider them far away from you? No, you don't. So, to figure out what the two remote angles are, look at that exterior angle, figure out what angle in the triangle touches it. Isn't this angle C here? What are the two angles that are left over? A and B. So A right here and B right here, these are your two remote angles. Right here and right here. So how does the theorem work? Let's say that the exterior angle is equal to 160 degrees. That means that these two angles here have to add up to 160 degrees. So if angle A is 50 degrees, what would angle B be? 110 degrees. All I did was subtract 50 from 160. And then, so all I would have to do would be to give you this exterior angle and one of the two remotes. Because when I gave you the 50, couldn't you get this one? Can't you get C also? You can get C two different ways. It either forms a linear pair here, or you add these two together and subtract them from 180. Don't these two add up to 160 though? What's left over out of 180? So wouldn't that be 20 degrees? So our exterior angles are very important to helping us find angle measurements. So let's look at an example. A little hairy of an example, but an example nonetheless. I want you to draw the following. Can I flip this? Make it snappy. Okay, so here's your second example and the last example of the day. We're going to use all of our prior knowledge of angle relationships with parallel lines and our knowledge of the three theorems. So, example 2. Find the measure. Write this down, Ryan. Of each numbered angle in the figure below. And oh, by the way, line AB is parallel to line CD. And here's what the figure looks like. Use your graph paper. Bless you. And then we also have a triangle in the middle of the two parallel lines. Doesn't this triangle create two transversals between those two parallel lines? So think of them as transversals. This angle is angle 5. This is angle 2. This one is 60 degrees. Below, this is 135 degrees. This is angle 1. This is angle 3. And this is angle 4. So we have 5 angles to find. Now let's talk ourselves through a couple of things. On your diagram, which angles are considered exterior angles to that triangle? What would be an exterior angle? Here's the deal with 5. If I extended the side of that triangle right there where 5 is, does 5, or I guess I would really have to extend this side, wouldn't I? Because here's 2, the interior angle of the triangle. I'd have to extend this side. Isn't it really this whole angle here that would have been the exterior angle? Does 5 and 2 form a linear pair? So they don't add up to 180, do they? So 5 is not an exterior angle. But 5 is what to 1? Alternate interior. So what do we know about 5 and 1? They're equal. All right, name me an exterior angle then. 5's not it. 4. Isn't 4 1? 4 is found by extending this side of the triangle. Doesn't 4 and 3, which is on the interior of the triangle, form a linear pair? 4 is an external angle. So if that's an external angle, which two angles are the remote angles? 1 and 2. So doesn't 1 and 2 add up to 4? Right? All right, isn't 135 the other external angle? All right, so what are its two remotes? 2 and 3. So let's go ahead and find our answers. All right, so what are we going to start with? We know 35 and 60. Where can we go from here? There's a lot of paths. 60 and 3 are alternate interior, right? So isn't this also 60? Okay. Doesn't that mean that I can find what from here?
2 and 1.
Not quite yet. We have to find 1 first, because 1's supplementary to 135. So what's 180 minus 135? 45, right? So isn't 1 45 degrees? Now I can find 2, Ryan, right?
Yeah.
So what's 45 and 60 give you? 105. What's left over for 2? 75. Where can I go from here?
Add 75 and 45.
Right, 75 and 45. Very good, Ryan. 75 and 45 are the two remotes. Don't they add up to give you 4? What do they add up to? 120 degrees, right? How do I find 5? You could add 60 and 75 and subtract them from 180, because don't those three angles add up to 180? The easiest way, though, without work, would be 5 and 1 are alternate interior. So aren't they the same? So no matter which way you do it, you should still get 45 degrees for 5. Does that make sense? Okay. I didn't get 40.
I mean 4.
Oh, 4. See the two remotes here? 1 and 2. Aren't they remote to 4? 75 plus 45 is 120. Does that make sense? Okay.